Hello friends. So this problem is called rigid rod moving on a circle. So problem says a rod AB is moving on a fixed circle of radius r with a constant velocity v as shown in this figure. P is the point of intersection of the rod and the circle. At an instant, rod is at a distance x is equals to 3r by 5 from the center of the circle. So the velocity of the rod is normal to its length, and rod always remain parallel to the diameter CD. Find the speed of point P at this instant. So let us try to see what are the things that has been given. So this is the rod, this is AB. So AB is the rod. And this diameter is CD. And the point of intersection between circle and this rod is P. And this rod is moving in this direction with velocity v. And v is basically perpendicular to the direction of the rod. This distance is given. At some point of time, this distance is x, which is equals to 3r by 5. So now the question is, velocity of this rod is given, and you have to find what is the velocity of point P. So how will you find this? So I give you a hint. What you can do is you can take component of velocity and then you can equate. So you can try yourself, and if you are not able to do this, then you can continue with the video. So now let us see how we will do this. So let's say this angle is theta. So basically we can calculate what is this. This distance is x and this distance is r. So we can calculate sine theta. Sine theta will be x by r, and x is given, that is 3r by 5. 3r by 5, and this divided by r. So from here I have sine theta is equals to 3 by 5. Now this angle is theta. So this angle will also be theta. Now see, the point P is basically moving on this circle. So point P was at some point of time, it was here, and the velocity is like this. At another point, this was here, velocity is like this. At this point, this is here, and the velocity is like this. So let's call this velocity as v dash, which is the velocity of point P. Now this point is a part of circle, as well as this is also a point of rod. So point P is a point of intersection. So what we can say is the component in this direction will be v dash, and this angle will be again theta. So this angle is theta. So this is v dash cos theta. Now see, this point P is on the both, on the rod or on the circle. So if you consider rod, then in this direction, the velocity of a rod is simply v. But if you consider point P on the circle, then velocity in this direction is v dash cos theta. So this means these two things has to be equal, then only we can say. So what we can say is, so from here we can say v dash cos theta is equals to v. Why we are saying? Because this velocity is coming from circle, and this velocity is coming from rod, and point P is on both. So this point is a part of circle, as well as this is a part of rod also. So from here we can say v dash is equals to v by cos theta, and cos theta is nothing but sine theta is 3 by 5. So cos theta will be 4 by 5. So from here we can say v dash is equals to v divided by 4 by 5. So that is v dash is equals to 5v by 4. Now I give you a question. what will be the velocity when this rod finally reaches here? So what will happen? This rod is moving. So at some point of time, this rod will reach here. So at this point is P. So you have to find what is the velocity of point P when the rod just touches the circle. So what is the velocity of point P at this point of time? And we also plot velocity of point P as a function of theta. So there are two questions. One question you have to find what is the velocity of point P when this point just touches the circle, and what is the function of velocity as a function of theta. So this means how the velocity of point P changes with changing theta, where theta is this angle. So you write the answer of this question in the comment box, and we will see you in the next video. Thank you. See you. Take care. Bye.